Hello and welcome to this video on the properties of 2D shapes as part of our Functional Skills Maths course at levels 1 and 2. The lesson objective is to identify and describe the properties of basic two-dimensional shapes. The linked learning relates to measures and the fact that we've already talked about one of the dimensions of shapes when we talked about length. When we're describing our two-dimensional shapes, there are some buzzwords we need to use to describe the shapes. For examples, sides and corners, angles, and base. The two-dimensional shapes we'll be covering on this course are triangles, four-sided shapes such as squares and rectangles, commonly grouped together as quadrilaterals, pentagons, hexagons, and circles. Let's start with our first shape, our triangle. A triangle consists of three sides, and depending on the length of the sides and the size of the angles, depends on how we describe those triangles. See if you can remember what these triangles are called. Okay, the first triangle we're looking at here in grey is called a scalene triangle. This means all of the sides have different lengths, which also means all of the angles are different. The second triangle is an isosceles triangle, where two of the sides have the same length. And in maths, to notify this, we put a little line, a single line, to show this side is the same length as this side. Now, if those two sides are the same length, then these two angles must also be the same. So an isosceles triangle is a triangle that has two sides the same length, or a triangle that has two angles that are the same. Therefore, two of the sides will also be the same length. The next triangle is an equilateral triangle. This is where all three of the sides are the same length, which also means all of the angles are the same. Now, a bit later on in the lesson, we'll describe the angles in a triangle, but an equilateral triangle must have an angle of 60 degrees for each of these three angles, because the angles in a triangle add up to 180 degrees. Our final triangle is a right angle triangle, and it kind of does what it says on the box. One of your angles is 90 degrees, therefore it is a right angle. Our next shape is a square. It is a special four-sided shape which has four sides all the same length. It has four corners, and each of the angles at the corners are 90 degrees, because the angles inside a square add up to 360 degrees. Our next four-sided shape, commonly known as a quadrilateral, is a rectangle. Now, a rectangle is similar to a square, where the sides at either end are the same length. So these two at each end are the same length, and the top and the bottom are the same length, but they are different to each other. And again, there are four corners each with angles of 90 degrees. Now, if it's 90 degrees, you notice I'm drawing this little square in the corner. Again, the angles inside a four-sided shape add up to 360 degrees. There are other four-sided shapes called quadrilaterals, and depending on how the sides relate to each other depends what they're called. So we've already had the square and the rectangle. So a shape where the top and the bottom are parallel is called A trapezium. A four-sided shape that has two sides the same that are adjacent but are at different ends is called a kite. A rectangle pushed on its side is called a parallelogram. And if it's a square pushed on its side and it looks similar to this, then it's called a rhombus. And finally, a four-sided shape that has got all different sides is just an irregular quadrilateral. Now, what all of these quadrilaterals have in common is that their angles inside the shape all add up to 360 degrees. And we'll look at this a bit later on. So a parallelogram has two sides parallel and another two sides parallel, where this length is the same as this length and the top is the same as the bottom. The angles here and here are the same, the angles here and here are the same, and all of the angles add up to 360 degrees. And it's essentially a rectangle that has been pushed over slightly over to one side. A rhombus is essentially a square that has been pushed slightly over to its side. So all of the sides are the same length. This angle is the same as this angle is the same as this angle, and the angles inside the rhombus add up to 360 degrees. A trapezium has two parallel sides where the angles can all be different, and the angles inside the shape add up to 360 degrees because it has four sides. A kite has adjacent sides the same length. So the two sides at the bottom are the same, the two sides on the top of this kite are the same. The only two angles that are same are these two, whereas this and this can be different, but all of the angles add up to 360 degrees. And finally, irregular quadrilaterals, where none of the sides are the same length and all of the angles are different. But, as with all four-sided shapes, these four angles add up to 360 degrees, as they would in this shape. Now we've covered a few of our basic shapes, we're starting to see a pattern of the angles inside those shapes. So for our three-sided shape, our triangles, doesn't matter what the triangle is, the angles inside the shape add up to 180 degrees. And with our four-sided shapes that we've just looked at, the angles, 4 lots of 90, add up to 360 degrees. So with this knowledge we already have, we can see that every time we add a side to our two-dimensional shape, we add 180 degrees. So for our five-sided shape, the interior angles will add up to 540 degrees. And for our six-sided shape, the interior angles will add up to 720 degrees. So it doesn't matter how many sides the shape has, we now have a process for working out what the interior angles all add up to. Our next shape is a pentagon, and a pentagon has 5 sides, and if it's a regular pentagon, they will all be the same length. The angles inside the pentagon, if it's regular, will all be the same, and they will all add up to 540 degrees. Our next shape is a hexagon. This has 6 sides, and if it's a regular hexagon, all 6 sides will be the same length, and all of the angles will be the same, and they add up to 720 degrees. Our final shape is the circle. The circle has no corners and just the one edge that goes all the way around. The properties of the circle and any calculations we do with the circle will be at level 2 only. What you need to be aware of is that for each of the shapes that has 3 or more sides, there are 2 classifications of the shape, regular or irregular, and we've mentioned this as we've gone through our shapes. A regular shape has all of the sides the same length, so a regular triangle is actually an equilateral triangle. An irregular triangle could be isosceles or scalene or a right angle triangle. The only regular quadrilaterals are the square, where all of the sides are the same length, or the rhombus. Now don't forget, the rhombus was a square pushed on its side. Irregular quadrilaterals are all of the rest. For example, a kite, a trapezium, a parallelogram. So anything with sides that aren't all of the same. Now this makes things quite interesting when we come on to our regular and irregular 5- and 6-sided shape. So a regular pentagon looks very familiar where all of the sides are the same length. But any shape with 5 sides of different lengths is an irregular pentagon. A regular hexagon, similarly, looks like this shape, whereas an irregular pentagon is any shape with 6 sides with different lengths, like this shape on the right. And that is the end of the lesson objective, which was to identify and describe the properties of basic 2-dimensional shapes. So dimensions are the 2 dimensions that represent our shape, so the length of the sides. A side is one of the dimensions. A corner is where 2 of our sides meet, and an angle is created where our corner meets. The base of the shape is effectively the bottom of the shape. This concludes the lesson on identifying 2-dimensional shapes and their properties. If you'd like more practice with these shapes, please ask your teacher. We hope you've enjoyed this video.